Today we're going to learn about what's called function notation. So before we get too much into function notation, we want to kind of refresh here. When we plot points, we consider the x, or the independent variable, as our input and our y, or dependent variable, as our output. So we got to remember that x, independent, input all go together, and dependent and output and y all go together. The independent variable will always control the dependent. And there's a little visual here. So the independent will go into effect. It will influence the change in the output, or the dependent variable. So some examples of this could be, as time goes on, you get taller. So therefore, time affects height. Another example is, as your brain grows, you get smarter. So you could say that your brain size controls your IQ, your intelligence. So what I want you to do is I want you to come up with your own. So as the years progress, what is something that tends to happen in life? It can be anything you want. So as long as it makes sense, that's fine. So come up with your own scenario and then have a teacher check your work. So what we do is we take this independent, this dependent input-output thing, and we think of it in terms of formulas. What we put into a formula, what we substitute into a formula, always controls your outcome, what you get out of it. So if I plug 2 into a problem, I'm going to get an answer from that. So we want to get used to that input-output sense. So we use the words input and output for that very reason. What you put in controls what you get out. And it's just like taxes. And you can ask your parents, when you have taxes, you have to put so much money into the government. You have to give the government so much money. So that way when tax returns come, you get some out. And the way we show these formulas is a notation that looks like we'll use x and f parentheses x. So instead of x and y, we're going to use x and f parentheses x to show those formulas taking place. And if we remember, f parentheses x is the same as y. So these are the same thing. It's just a different notation, that's all it is. We pronounce this as f of x. So this f parenthesis x is pronounced f of x, a function of x. And this is what we call function notation. And all it really means is the outcome of the problem. So this formula depends on what we plug in for x. So if I plug 2 in and then I plug 3 in, I'm going to get different answers based on what my formula is. So we're going to use these things for a little while. These are called function machines, and it kind of gets you into that mindset of putting in to get something out. So when we see the letter out here, that doesn't mean f times x. This means the name of the function, or what the formula is, and this stands for what you put into the formula or the machine. So the idea is we take an x, an independent variable, we put it in hence the name input. The function machine will use some formula and kind of take that x and do stuff to it, and then it spits out our answer, which is why we call it an output, or f of x. So again, you put a number in for x. So I could choose to put 3 into the machine. It's going to do stuff. It's going to use a formula to get to do something with that 3, and then it's going to spit out an answer. That's the idea. So we're going to use this function machine, and it looks like the formula is x plus 2. So that's the formula we're using. So we're going to put 3. We're going to dump the number 3 into the machine. And the key is looking at our x's, because remember, you're putting in a number for x. So what would happen is I would take this x out and put a 3 in its place. So everything else stays the same, but instead of x, you write 3 everywhere you see x. So it'll look like this. And this is all going on inside the machine. And what we do is we look here and it says 3 plus 2. Well, that's 5. So therefore, our output is 5. So we read this as f of 3 equals 5. And that means, hey, when I put 3 into my formula, I got 5 out of it. And 5 is my answer if I choose to use 3. If you choose to plug in 2, you're going to get a different output. So we're going to try a different function machine. This time the pattern, the formula, is 2x plus 1. And we're going to put 2 into our machine. So again, I always look for my x's and I mark them everywhere I see them. And instead of x, we're going to replace it with 2. So it looks like I have a 2 right here, and I'll have a 2 right here because that's where x was. So now my machine is thinking and thinking, and it does 2 times 2, which is 4, plus 1, which makes 5. So when 2 is the input, 5 is the output. So what we're going to do with these is we're going to take the idea, we're going to pretend each of these tables is a function machine. You have a formula on the machine, and these are your inputs. So the way we do this is what our function machine is going to do. Instead of f parentheses x, it's going to say f of 8. And instead of x plus 1, it's going to be 8 plus 1. And when I add 8 plus 1, I get 9. We're going to repeat the same thing, but this time the input is -1. So this time, instead of using 8, I use -1 in my formula everywhere I see an x. So again, 8 to -1, and -1 plus 1 is 0. So when -1 is the input, 0 is the output. When 8 was the input, 9 becomes the output. So it will always be changing because the formula controls it. So you're going to go through, and I want you to try tables 1 and 3 on your own. And as you're working, you'll see the answers appear in these tables and you can check your work. And if you are falling behind, feel free to pause the video and take as much time as you need. And number 3, be careful. This is a new machine. There's a new formula, so you have to be using the 2x minus 3 formula. Check your answers with the ones that have appeared and see if they match up. If they do, then it seems like you know what you're doing. That's good. If not, then this will be the time to call a teacher over and ask for help. Now, 2 and 4, you're going to try on your own. The answers are not going to appear. If you think you have 2 and 4, you must raise your hand and ask a teacher to check your work and see if it is correct. But notice in number 4, there's no X here. You must make up your own. So you have to pick something that has not been used as an input, make up your own input, and then get your output from that. Please pause this video so that it doesn't exit while you're working. So the last couple problems you're going to do are problems like this. So it's just like what we did before, except this time I have f of x and a g of x. And that's okay. All it means is these are different machines. So this would be the f machine, and this is the g machine. So if I look at number 5, it says G. So right away, I know I need to use the G machine. And if we look, the G machine says the pattern is 2x plus 2. That's the formula. Since they want G of 1, you need to figure out, okay, 1 is the input. So where I see an x is going to become a 1. So this is going to be my output. So you would write 2 parentheses 1 plus 2 because instead of x you put 1. And then if you simplify that, you will get that g of 1 is 4. And that means when 1 was the input in the G machine, I got an output of 4. And then I always circle my answer when I'm done. Now number 6 says f of 5. So you need to use the f machine. So f parentheses 5 equals 3 parentheses 5 because we take out the x and we put the number in its place. So you're going to go through and do 6, 7, and 8. If you think you have your answers, then you must raise your hand and ask a teacher to come check your work.